All right, some terms we got to know before going on to the back side of the notes and looking at ray diagrams. First of all, the principal axis is a line that's drawn through these 3 points: the center of curvature, the focus, and what's called the vertex. All of these points, or this exact picture actually, is up on the top of your notes. You might want to draw arrows to these things or label them to make sure you know what they are. But the principal axis is just this center line here. The vertex is the one that's not labeled. That's where the mirror crosses the principal axis, and it's this point right here, both with a convex and a concave mirror. Where the mirror crosses the principal axis is called the vertex. Center of curvature, you'll notice that this is part of a circle. By the way, a concave mirror doesn't have to be circular. It could be parabolic or whatever else. But this particular one is a circle, which means if we carry it on around, the center of that circle is called the center of curvature, center of the circle. And the focus is the point where the light rays converge if they're coming in parallel to each other. They'll come in parallel and all converge at the focus. Notice that for focus and center of curvature, I have 2F and F written. And the reason for that is because if this is a circle, the distance to the center of curvature from the vertex is the radius. And the focus is always half the distance to the radius. So this distance is F, which means this distance would be 2F, which means if it's a 2 centimeter focal length, let's go ahead and go to focal length, that's the distance from the focus to the vertex. If the focal length is 2 centimeters, that means the distance to the center of curvature, or the radius, is 4 centimeters. Okay, let's go ahead and go to the back side of the notes. And let's look at drawing ray diagrams. The first thing we have to do before drawing ray diagrams is understand why we're doing it. You might want to write this down, that the purpose of a ray diagram is, well, first of all, let's set this up. We're always going to have an object indicated by an arrow in front of a mirror. And that object, there's going to be an image formed of that object by this mirror. And what a ray diagram does is it allows us to, first of all, know where that image will be formed and what it looks like. So we want to know where the image is and what it looks like with these rays. To start with, at the top of your notes, you have ray number 1, number 2, and number 3. You might want to put a star by those because you need to memorize these. We're going to go through them slowly at first, but you need to be able to memorize them to where you'll be able to do them very quickly. These are principal rays, rays that we have picked out on purpose to make it easy to know where the image is. In actuality, there are many more. There are an infinite number of rays coming out from this arrow. From the tip of the arrow, and we just happen to pick these because they help us locate where the image is. So let's start with ray number 1. Ray number 1 starts at the tip of the object, right here, tip of the arrow. We always start every ray at the tip of the arrow, and it gets sketched horizontally toward the center of the mirror. Really, what that means is parallel to the principal axis, parallel this line. So ray number 1 looks like this, right? Now, ray number 1 doesn't stop there. We know it continues on. And ray number 1 gets drawn reflected off the mirror. It doesn't reflect straight back because of the shape of the mirror there. It obeys the law of reflection at that point, and it gets reflected through the focal point. So ray number 1 looks like that. But remember that if your eye is here, it doesn't know that the ray came from here. It traces a virtual ray back here. So behind every ray of light, every reflected ray of light that is, we're always going to extend a virtual ray behind the mirror, behind the reflected ray, not behind the incident ray. So the virtual ray always goes here. Do not put a virtual ray behind the incident ray because your eye doesn't see this light. It sees this ray coming from here. So that's ray number 1, and we'll say this very often. You need to be able to repeat it. Ray number 1 goes parallel and then through the focus. 1 is parallel and then through the focus. Ray number 2 is really easy to remember because it's exactly the opposite of this. So ray number 1 went parallel and through the focus, and now ray number 2 goes through the focus and then is reflected parallel. So ray number 1 went parallel through the focus, number 2 is through the focus and parallel. Now right now you need to know that this is on the exact same picture in your notes, on that top diagram. We're not in the bottom diagram yet. So if you sketch this, you're going to stay on the exact same image that you were before. Don't move down to the bottom. You'll sketch it over ray number 1. So ray number 1 you should have drawn parallel through the focus. Ray number 2 is through the focus and then parallel. And remember, there's always a virtual ray behind the mirror, behind the reflected ray, and we extend it right here. There's our virtual ray. So there's ray number 1 and ray number 2. Most of the time, that's all you're going to need. You only need two of any of these three rays, but we need to know at least three of them to get us through every type of mirror that we're going to have. Ray number 3 is fairly easy. Again, we start at the tip, and what you would do is put a straight edge along a line that goes through the center of curvature to the mirror. This ray goes to the mirror along that line and hits the mirror at a 90-degree angle here, and therefore reflects back on itself through the center of curvature. So ray number 3 looks like this. It went from the tip of the arrow to the image and is reflected back on itself. Therefore, this entire line really is a reflected ray, and behind every reflected ray, remember, is a virtual ray. So ray number 3 should look like this. Now, your picture is not exactly drawn to scale, so yours may not look exactly like the one I'll show you, but at this point, you should have a picture on that diagram that looks something like this. Something like this. The point of an array diagram is that we want to answer these three questions. We want to know where the image is and draw the image. And then, and very important, I want to know, is the image real or virtual? Is it upright or inverted? And is it magnified or reduced? As far as locating the image appears where the real or virtual rays cross, where they intersect. And again, reflected rays are always behind the mirror, and they create the virtual rays. So let's look at this image. In your picture, you don't have a picture of the image drawn here. You're going to have to locate where it is. Notice that all of our rays, all of these rays that we drew, the reflected rays intersect at this point. Now, it's common for people to get confused and think that this is the intersection point. After all, two rays do intersect here. But this is an incoming ray, and this is a reflected ray. Rays that are going opposite directions cannot form an image. We want the image to be formed by either the reflected real rays or the reflected virtual rays. So the image will be formed here, and the way that we draw the image is, remember that we always started the rays from the tip of the arrow. Therefore, where the rays intersect is where the tip of the image will be formed. And the base of that arrow will stay on the principal axis. And the reason for that is if I send a light ray directly into the mirror, it's going to bounce off the mirror at 90 degrees here, and it's going to come straight back on itself. So the base of the arrow always stays on the principal axis, and the tip of the arrow is wherever those rays cross. Now, we got to answer these questions. First question was real or virtual? Well, it's real rays that are intersecting here. Notice that the virtual rays are diverging away from each other. They do not intersect. So we have a real image here. We have a real image, and this image is inverted. I know it's inverted because I can see it when I draw it. I also know it's inverted because a while ago we found out that all real images are inverted. So just because we know it's real, we automatically know it has to be inverted. But I also know that because I started the rays above the principal axis, and they intersected below the principal axis. So there's three ways to know if the image is inverted or upright. If it's upright, they'll intersect above the principal axis. This image happens to be magnified because it's actually larger than the object. You can only know that when you actually draw the image and compare it to the size of the object. To be honest with you, I'm not very concerned about this magnified and reduced question because it requires that you draw the picture perfectly, and that's sometimes it's impossible to do. So this is a real inverted magnified image. All right, let's look at the one down at the bottom now, the convex mirror. Notice at the top we had a concave mirror. You should have all your rays drawn on this one. This would be ray number 1. This would be ray number 2. And there's a virtual ray here, virtual ray here. This would be, for ray number 3, we would have had to extend this mirror, so it would be here and then coming back on itself. They all intersected here, and there's our image. Virtual ray. Remember, this mirror has a positive focus, which means the focus is in front of the mirror. Now we're dealing with a convex mirror. Convex mirrors, remember, have a negative focus, which is back here behind the mirror. So there's our focus, and there's our center of curvature. Now, it helps if you have a straight edge, obviously, as I said before, and it helps to know what rays to draw. In this one, we're only going to use ray number 1 and ray number 3. Number 2 works, and I'm going to go ahead and draw it to show you that it does, but number 2 is a little bit confusing. So I recommend just doing number 1 and number 3, and it's the easiest. Now, This can get confusing, so just bear with me. Ray number 1 verbally is the same, but it's going to look different because the focus is on the other side. So with ray number 1, we again start at the tip of the arrow and we sketch the ray horizontally toward the mirror, parallel to the principal axis. Now, ray number 1 said parallel to the principal axis, and then it was reflected through the focus. That's still the truth, but now the focus is back here. Okay? But a real light ray can't get back there. Real rays don't go through the mirror. And it's not going to reflect down here. This is not the focus anyway. Not to mention that disobeys the law of reflection. That can't happen. This is a diverging mirror, so all these rays have to go away from each other. So what we have to do is take our straight edge and create a line from that striking point to the focus. The real ray doesn't get back here. The real ray is reflected off of the mirror on that line, and it's a virtual ray that goes back here behind the mirror through the focus. That is ray number 1. So that's what ray number 1 looks like. Verbally it's the same, parallel and then through the focus, but the real ray doesn't ever go through the focus. A virtual ray does. Ray number 2 I'm going to go ahead and draw, but remember we're not really typically going to use it. Ray number 2 is just the opposite of number 1. It goes through the focus and then parallel. So I'm going to start my straight edge going toward that focus. So the ray comes from the tip toward the focus, but it can't pass that point. The real ray doesn't get back here. It gets reflected, as ray number 2 says, it's reflected parallel to the principal axis. So this ray, the real ray goes here. Behind every real ray is a virtual ray. So there you go. There's ray number 2. Again, I would not recommend that you do ray number 2 because a lot of people get confused by this whole turning thing and figuring out where exactly it goes. If you want to use it, that's fine, and this should be where our image is here because this is where the rays are intersecting. But let's go ahead and do number 3 and be done with it. Number 3 goes through the center of curvature and it's reflected back on itself. That's pretty easy to do. Here's our center of curvature back here. So we're going to start from the tip. Don't go through the focus. We already did that one. Go through the center of curvature. Real ray goes here. Again, cannot pass the mirror, so it gets reflected back on itself on a line that goes through the center of curvature. This is now a reflected ray. Therefore, we're going to draw a virtual ray that goes through the center of curvature, and voila, look, our virtual ray intersected where all the other ones did. And now we have to figure out this image. I'm going to go ahead and draw the image right here, and now I can answer some questions. Is this image real or virtual? Well, the virtual rays are intersecting and the real rays are diverging away from each other. So this is a virtual image. Since it is virtual, I know it has to be upright, no question. And if I look at my picture, it is upright compared to the picture, to the actual object, because we started the rays above the principal axis and they intersected above the principal axis as well. This image is actually reduced. It's smaller than the object. And if I were you, I would put a star by all these because this will always happen with a convex mirror. Always. You're always going to get a virtual image. It's always going to be upright. And it's always going to be reduced, which is why in that bus mirror, you always look small and upright. Always, always. Here's me. Here. You'd rather see me, right? Woo, woo. So there's your convex mirror ray diagram. In the next video, I'm going to do a few ray diagrams with you just for practice.